Hey everybody, it's Tony from Adafruit, and I wanted to do a Raspberry Pi quick look at a piece of software called Node-RED. And it's something that actually comes pre-installed in the versions of Raspbian operating system. And I've always seen the icon there and wondered, like, what is this Node-RED thing? You know, what can you do with it? How does it work? Is it interesting? And so I thought, let's just kind of play with it a little bit. You know, I'm not really an expert in it. I've just used it a little bit, enough to kind of learn some things and maybe show you some real basics with it. But it looks like a cool kind of platform. So let's just kind of dive into it. I'll go through a few little demos with it, and then we'll see what we can do. So we'll jump to the main view here. We'll turn everything on. And basically in the upper right here, I've got the workbench shot. And I just have a Raspberry Pi 3, and it's connected to a breadboard. I have the little DHT temperature humidity sensors. I've been using those in the last two Friday live stream videos, so those are still connected. And we'll kind of see, like, you might be able to use these with Node-RED, but there's some caveats. I ran into some problems. I also have an LED connected to one of the GPIO pins on the Pi, and then there's a little switch right behind it right here, my finger's on it. A little momentary switch, and so we'll see how we can use that with the Node-RED environment. But just to kind of get started, so I have the web page right here for Node-RED. It looks like it's nodered.org. And from what I understand, oh, I just lost a battery on this light over here. So hey, we'll have more dramatic lighting, it looks like. Anyways, though, so from what I understand, it's a tool I think that either IBM created or has a lot of backing to it. It looks like it's open source, but it's you know, basically a visual tool for writing Internet of Things applications. And from the little bit that I've played with it, I would almost call it like Scratch for grown-ups, in that it's a visual language. You know, you arrange blocks and you link things together, but it's not so much targeted at like the complete beginner to programming. I think it's meant to make things a little easier so that, you know, you have like Internet of Things flows of, you know, you want to talk to a web service, get some data, maybe make a decision based on some state there, maybe read some stuff from hardware, maybe the hardware itself controls like what web service you need to talk to, and then maybe output something somewhere. So that kind of stuff where it could be a little daunting, you know, if you're new to programming, if you've only just done like some basics. So I think the goal or the idea with this is that it can turn creating these kind of complex workflows almost like if this then that, if you've used that service where you hook up real simple things of like, if this event happens, then send an email off to me. Same basic idea it looks like, but running locally on your Raspberry Pi. So it's, you know, there's not some cloud service that you're depending on. It's some software that's actually already there and installed and ready to go. And so they kind of mention on the homepage, and by the way, I'll put links to all the web pages and things I talked to down in the description below. So check that out when this goes up on YouTube, and you'll be able to see that. But this kind of tells you, you know, Node-RED, it looks like you can install it on other platforms than just the Raspberry Pi. It's not dedicated to that, but you'll see it has some little special extras for the Raspberry Pi inside of it. So that's kind of cool. Like, it looks like it could work on, you know, your laptop or whatever. It's all based on Node.js and JavaScript. So if you're familiar with that environment, it looks like you'll be really comfortable with using it and extending it. But you don't have to get your hands too dirty with JavaScript with this. So, you know, don't worry too much if you're not super familiar with it. And then the other thing that I should point out is they have a really good little Raspberry Pi getting started guide here that really is worth reading through, because there are a lot of little, I wouldn't say like rough edges, but gotchas with this, where it's like you really need to make sure, like they're telling you, know, install this specific version of NPM, the Node Package Manager. And, you know, like those are the kind of things where if you just kind of go in and think, oh, I need NPM, I'm just going to install the latest version, suddenly things start breaking. And so I ran into a lot of little issues like that. So follow the documentation like to the letter from what I've seen, and you'll hopefully run into as few problems as possible with it. So that's just a little kind of note there. But yeah, check this out, skim this page. It's really good. It goes into a lot of detail of getting it set up, how to access different parts of the hardware with it. So it's a great little resource there. So let's just kind of dive in. Now on my Pi, like I mentioned, I set up the latest version of the Raspbian Jessie operating system, and you really want to grab the latest version because it's only in the last few versions that they've added Node-RED, and it's, you know, it's there out of the box. There's really nothing else that you need to do. You could probably update it if you wanted to, you know, make it a little more recent version. And oh, there comes the cat. So she's I guess she has some feelings about Node-RED here, so might see a little visitor. So anyways, I'm going to connect to the Raspberry Pi in an SSH terminal right here. So I've just, you know, I've loaded up the latest version of Raspbian and Jessie and get the full version, not the light version. I don't think the light version includes Node-RED. You could install it in the light version, I'm sure, because it is really just a Node.js text application. There's no GUI or anything like that that you need for it. But then connect to your Pi, and it's really easy to use it. You just want to run the command. Well, first you want to run raspi config, go through, and run that as root, obviously. So go through and do the expansion of your SD card. That's just your standard Raspberry Pi setup. So, I'm just going to finish out of here. I already did that on this card, but that's the only thing I've done. And then you just want to run node-red start. And this command will just start up the Node-RED server. So the way it works, it runs as a little web server on the Pi, and then you connect to that from your web browser. And you could do this in the GUI on the Pi. Like you could load the Pi desktop and use the Pi web browser. I'm going to do it from my machine right here, just because it's a little faster than using the Raspberry Pi web browser. So, okay, so it starts up, and you'll see some text here, and it kind of tells you once it's started, point your browser at this address right here. Now you might be a little confused, and this is kind of like a rough edge, I think, where once it starts it says, hey, the server is running on 127.0.0.1. If you don't know though, that's the local host address, and so if you try to access this from your machine outside of the Raspberry Pi, it's not going to work. So this is the IP address of the Raspberry Pi. It looks like it found it from the network interface and kind of tells you that. So let's just go right into a web browser and hit that address here. And you'll see it just boots up, and it's got a nice clean little graphical user interface. And so, like I said before, the basic idea from what I understand with Node-RED is that you have a whole bunch of little blocks on the left here. And these could be things like there are a whole set of inputs, which mean that they produce some kind of an output. So there's like an inject input where you can just manually inject something. And if you mouse over them, it's kind of nice. It gives you a little bit of a description here. Or like, for example, here's an MQTT input. So you configure this to talk to an MQTT broker, like maybe Adafruit IO or something like that. And then when it gets a certain event, it can trigger something that goes further into your flow, because this whole work area here in the middle, this is a flow, which is really just where you connect all these blocks together and then create different things inside of here. So you've got inputs, there are also outputs here, and so there's a whole kind of interesting set of outputs that they have. Like there's a debug output that'll just put some text out there. The MQTT output can send to an MQTT service, for example, web request stuff, raw TCP, UDP. So that's pretty cool. Like that's the kind of stuff where if you're writing that code by hand, it can be a little tedious, it can be a little daunting. So it's kind of neat if you can actually do some of this stuff graphically by just dragging things together. There's some functions which basically transform, they take an input, they do something to it, and then they send that input off to another node. And the one really interesting one is a function block where you can actually just drop in some JavaScript code. So if all of these blocks don't really do what you need them to do, it looks like you can just put in your own JavaScript and go crazy with that. So that's pretty interesting. You've got the capability, and it looks like there's a whole lot of different ways you can deal with data. Like they've got CSV, HTML, JSON kind of parsing stuff. So that's kind of neat. So there's a bunch of social blocks where, like, this reminds me of if this then that, where maybe if you receive an email, or if you can send an email, that type of stuff based on certain events. Storage, this is kind of cool. Like if you have maybe sensor readings or things like that, you can store them into a file like that. And then way at the bottom, they've got a few Raspberry Pi specific ones here. So these are kind of interesting. You can control some of the GPIO pins on the Pi, or you can also like listen to a GPIO pin, like a button, and see if it's been pressed or not, and maybe take certain actions from that. And these are just the basic ones that you get out of the box. If you go back to the Node-RED website, they actually show you here, they've got a whole set of kind of contributed nodes, and even I think flows. And a flow would be like a connection of a bunch of nodes, whereas a node is just a thing. So for example, like these DHT sensors that I've connected, I just did a little search, and I noticed there's a DHT library here, and there's actually two, and if you read the second one, it said don't use this one, it's been superseded. So okay, we'll go back and grab this one from here. And so it kind of tells you, okay, this can use the DHT 11 and 22 sensors, which are what I have connected to my Raspberry Pi right here. and it tells you a little bit about it. So that's kind of cool. I think the basic idea here is that they're probably hoping to have a little bit of an ecosystem. As you can see, like 788 things. There's a lot of stuff here. So I don't know. Like, let's just see. Do they have like an OLED display in here? Oh, they don't have that. Maybe let's see. Do they have any type of displays here? Fritzbox routers. Oh, I guess they don't have a lot of outputs. That's kind of unfortunate. But I don't know. Let's just see. Are there temperature sensors? Something like that. And yeah, here we go. DS18B20. That's a one-wire temperature sensor. All kinds of stuff in here. It looks like some interesting flows and things. So, check it out. Look and see if it has the hardware that you want to use. This could be a pretty cool thing to make it easier to build interesting apps with. And then if you're a JavaScript developer, from what I understand, you can go in and create your own nodes and flows. You just have to implement the right JavaScript stuff for this. So to get started with, I was just going to play around a little bit. We'll just kind of do some basic hello world stuff. Like I said, I have an LED and a button connected to the Pi right now. So we'll see if we can just do some basics of like blink the LED, read the button state, maybe do some stuff like that. And then I'll try really quickly to use the DHT sensor, but I'll show you I ran into some problems. And so I think maybe the DHT sensor library might have some problems right now, or I'll show you what I ran into. It's some of it is just typical Node.js native code stuff, which can be a little painful. But the most basic hello world, I'll show you. If you grab an inject node, which is basically a way to create your own little payload or message that's sent to something. And then if you grab the debug node, this is like a debug output node. And the nice thing is there's a lot of good documentation. If you click on a node and you're in this info tab right here, it tells you all about this. The debug node will listen to whatever payload comes into it and then print it out as like debug output that you can actually see in this little console right here. And then this inject node, this just creates an event whenever you press a little button right here on the left side. It's not super obvious, but this is a button right here, and you'll see once we start running this how it works. So by default, and if you double click these nodes, it brings up the configuration for the node. So by default with this inject node, it'll actually just send the current Unix timestamp down to the next node that it's connected to. So instead of doing that, let's just have it send a string, and we'll just have it send hello world. And it's going to send this in the payload of a message. So the things that get passed in between the nodes here are messages. And from what I understand, a message has a payload that's just some arbitrary set of data. Like it could be a string, it could be a number, it could be probably some like JSON structure, some state that gets passed between two things. There's also a topic associated with that, which I guess kind of means that it's not just like a single message sent over that channel. You could probably have multiple messages on different topics if you needed, which maybe might be a little more advanced than you went and get with stuff. And it seems like you can just ignore topic and you don't have to use this. It's also interesting the inject node can repeat, like it can send events at a certain frequency, almost like a cron job type thing. So kind of cool, but I'm not going to use that. So, basically when I press this button here, it's going to send the string hello world to whatever it's connected to. So we'll just say okay on that. And then my debug node here, I'm going to double click it. I don't need to change anything though. So basically it's going to read the message payload property and then output it to the debug tab. And it looks like you could also output to the JavaScript console, but we'll just keep it on the debug tab here. So we'll say okay to that. Now to connect these, you just literally connect. So this little guy right here is the output of this node. And then on the left right here, this is the input of this node. And so you can kind of see how the output of this, you just drag straight to the input there. And you can also see how this inject node, it doesn't have any inputs here. You can't connect something into this. You can only connect things into an output node like this. So just something to be aware of, that it's not like super hyper flexible. You can't just completely remake things, but that's kind of cool. Okay, so I just dragged that little connection. Now the thing I noticed, I think when a node has been changed, but it hasn't been deployed yet. So deploy is when you kind of turn it on and you say, I have my flow right here, now make it active, run, and whatever events happen, start processing them. But if you haven't deployed since you've last changed a node, I think that's when this little blue button or little blue icon comes up here. So what you want to do then is just click deploy. And so it says, okay, successfully deployed. And so now my flow is running. And if it had some events that maybe kicked off automatically, they would have started already. But right now, the way this thing works, when I press this, it's going to generate that hello world message, send it over to this debug output, and then hopefully print it out. So if I go to the debug tab here, and I press this guy there. So cool, successfully injected hello world, and then you see here's message.payload hello world, and so I can press that, and it goes and sends the output there. So that's kind of cool. It's just wiring things up and doing a simple hello world. So let's make it a little more interesting now. Let's go down and let's play with some of the hardware on the Pi here. So maybe let's do the output here. So this is basically, you can control one of the digital outputs on the Raspberry Pi. And so my LED, I have that connected to, let me double check, it is pin 23. So I'm going to double click this pin. And now here is a big gotcha. You need to be very aware of the pin numbering. So the default pin numbering on the leftmost column here is not the pin numbering on the Pi cobbler. It's actually the physical pin number on the connector, which isn't really common to use. So it's unfortunate that they chose that as the default, but that's what it is. Now the next column here, you might see these GPIO numbers and think, oh, okay, well, if I'm looking for pin 23, then I probably want GPIO 23 here. No, you don't, because this is actually, I believe, the wiring.py GPIO number scheme. So again, this is not the GPIO numbers on the Pi cobbler like that I'm using right here. So the Pi cobbler has numbers on here. You actually want the third column. This is the BCM pin numbering. That's basically the pin number connected to the BCM 2835, the processor on the Raspberry Pi. And so this is the number that matches up with the number on the Pi cobbler. And so I mentioned that this is a big gotcha because it's really easy to get this wrong. And you're like wondering, why is my light not turning on? Like, this is the most basic thing in the world and it's just not working. And it's probably because it's trying to light up the wrong switch here. So in my case, since I have BCM 23, I actually want to use this line, the GPIO 4 or pin number 16 on the Pi. So I pick that. It's a digital output. It also supports a PWM output, which is like if you want to dim an LED or maybe control a servo. So that's kind of cool, but I'm not going to use that. You could initialize the pin to a default level, like, on or off, but I'm just going to keep it at the default. And then maybe I'll give it a name. So we'll say this is the LED connected to the Pi. And I just want to double check that it is pin 23. So yeah, it looks like it's pin 23 right there. So okay, so there's my LED. So now I need something to connect into this. And if I go to the info, you can actually see it tells you digital mode expects a payload with either a 0 or a 1, which will set the pin value to either high or low based on that. So we can just use our inject right here, and actually maybe instead of injecting hello world, let's just inject a 1. Like, this should basically turn on the LED. And the cool thing is you can actually send this to 2 places. So this is going to send the message 1 to the debug output and then also the LED right here. So let's deploy this. And we'll go to our debug tab, and now let's see what happens when I press that. Hey, notice the LED just turned on. So it sent the 1, and then we also see the message there, the 1 that got sent. So that's cool. And then if you want, if I want to inject another thing here, like maybe I add this, and I can inject the string 0 if I want to be able to turn this off. So I'll do that, and then maybe I can connect this up to the LED. So it's kind of cool. You can have multiple things connect to this LED also. And we'll maybe send that to the debug output also, so it gets a little bit ugly, but that seems okay. So now I deploy this, and now I can press this, and see it turns off the LED, you get a 0 message. Press this, it turns it on. So that's kind of cool. It's just sending around basic messages like that. And like I showed before, so there are lots of different sources of data here. Instead of doing this inject, I could maybe have an MQTT node in here. And if I double click this, I've basically got to configure it and say, okay, I need to add a broker. So you've got to like configure a server here and all that stuff. Maybe a future video I might look at that. But the cool thing is it could listen on a topic, and if it gets like a 0 or a 1 from that topic, then it could pass that along and control your LED right here. So you haven't written any code. To do this with Python, you'd have to install like the Paho MQTT client, write a little basic loop. You can go back and see some of the earlier videos where I've used MQTT. And so there's some non-trivial setup that you have to do there. So it's pretty cool that you can just graphically go in and start connecting these things up and making them work like that. So, I'll delete that. These functions here are also interesting in that, you can kind of control the behavior of a program. So like the switch function right here, I noticed this is kind of like an if-else function where it takes an input value in, And then if you double click it, it has a bunch of conditions you can add. So it's going to look at the payload, and you can say if that payload equals, like a 0 or a 1 or maybe a string or something like that, then it'll feed to an output a certain value for that. So we'll come back to this one in just a second. But basically, let's see, I'm going to delete all of these. Let's go back and let's play with the little push button that I have connected to the Pi. So for this one, I'm going to want the GPIO input, which is this block right here. And so for this guy, again, the pin numbering, be very careful. With the Pi cobbler, I need to use the BCM numbers on the rightmost column. And for my button, I have it connected to pin 24, BCM pin 24 right here. So I'm going to select that one. Now for this one, because it's an input, the way I have this wired up, I have one side of the button connected to ground and the other side of the button connected to my GPIO 24 input. And so the easiest way to read a switch like that is if you set that input with a pull-up resistor, so that normally that input's going to be pulled up to a high logic level, and then if the button gets pressed, it connects to ground, and then that means that you get a low signal, and when the button's not pressed, it's not going to float to random values. It's going to get pulled back up to a high logic level signal. So just something to be aware of, that you do still, even though this is graphical programming, you still kind of need to know a little bit about the hardware of the Pi and how to read an input and things like that. So we'll say that's an input with a pull-up. I'm not going to say read the initial state, but that's kind of cool. It can just automatically send a message when you deploy or when it starts up. And let's call this button. And so we'll say OK on this. And again, if I read the info on this, it tells you it's going to set the payload to either a 0 or 1, depending on the state of the input pin. So that's kind of useful. We could hook that up to the LED maybe in a second. But just for now, I'm going to have this output to the debug output. So it's just going to print out whatever the payload is that it gets for this. So, okay, so I'm just going to double check. I've got, BCM24 with a pull-up. Everything's good there. So let's deploy this, and we'll open up the debug. And actually, I'll click this to clear the debug. And now let's see, when I press the button, hey, look at that. So I've pressed it down. I haven't released it. So it's showing 0. That means that it's connected to ground, which makes sense because it has a pull-up resistor. And when I release it, it changes back to 1. So, I can just press this a few times, and you see, you get all those 0 and 1 messages there. So pretty cool. That's pretty easy. There's no code that you need to write to make that work. It's just connecting things up. Okay, cool. So let's get a little more advanced with this now. Let's grab that switch right here and maybe throw this in front of it. And let's add a condition so when the message payload equals 0, which means when the button is pressed, it can do something. And then let's add a rule that when it's 1, so when the button is released, it can do something else. And so now you can see it has both those inputs. So the top one is when it's pressed, and the bottom one is when it's released. I also noticed it's kind of cool. They have a function in here, an exec function, which will basically run a shell command. So you can actually just have it do anything in here. I'm just going to have it echo hello world. So, but you could have this run your own script, or maybe, call a command like curl to download a file or something. You can do anything. It can append the payload, the output of your command, it can append the input that you get to the command that it's going to run, but I don't want it to do that. I'm just going to say, let's just run the echo command. We'll say maybe instead of hello world, we'll say button pressed. And so we'll say OK to that. And then let's do the exact same thing, but let's say button released. So we'll say echo button released. And we'll say, and we don't want to append the payload to that. So we'll say OK. And then maybe let's feed these into just a debug output for now. And so this exact thing, you can get the standard output, which is the top one, the standard error, and then I believe the result code of the command that ran is the third one. So I just want the standard output. So I'm going to connect both those standard outputs up. Now my switch, when the button's pressed, that top one gets fired, so it's going to echo that. And then when it's released, the bottom one gets fired. And then the button I'm just going to connect up to the switch right here. So in theory, when I deploy this, and then if I clear the debug, now we should see these messages when I press the button here. So hey, look at that. So I pressed it. It says button pressed. So that's pretty cool because behind the scenes, it just ran a shell command. It ran the button, the echo command, and I released it, and it just ran a shell command. So you can see the power there. If you've got a command on the Pi, like a script you wrote, it can run it without doing a whole lot of crazy stuff here. So that's cool. And then just for fun, let's add in the LEDs as an output here also. So let's see. Let's put the LED down here, and we'll configure this guy again. I think he was connected to pin 23. 3 was the LED. So yeah, so I want this one, digital output, maybe, yeah, let's initialize it to 0 to turn it off no matter what. We'll say LED. And then again, so I'll just take the output of this switch command here and we'll say, okay, feed, well, I don't even need to really use the switch command. I guess I could just use the button output directly. So there we go. So now it should light the LED up whenever I press the button. Well, actually, no, sorry. When the button's not pressed, the LED is going to be turned on because it normally has a pull-up resistor. And then when I press the button, the LED is going to turn off. So let's actually, well, here, how about this? Because I initialized it to a level of 0, let's initialize it to a high level. So the LED should turn on, and as long as the button's not pressed, it'll stay turned on. So we'll do that, and yeah, we see the button turned on, and then maybe I'll clear the debug output here. And so I'll press the button, and then you see, hey, notice the LED turned off, and then I release it, and it turns back on. And then you see the messages printed out right here too. So that's pretty cool. You know, it's pretty straightforward and easy. Like, notice, you know, I haven't written any code, and I've got a somewhat non-trivial program going on. Like, if you wanted to write this in Python, you know, you'd have to figure out how to have like a main event loop, and you've got to figure out how to use the subprocess command and get its output and stuff like that. So pretty neat. I think they're onto a cool idea with this. Now, the last thing I wanted to mention, you know, you can extend this with different libraries. And so, like I said, those DHT sensors, there's this Node-RED contrib DHT sensor. Now, the way that you're supposed to extend it, basically you want to stop it. So I'm just going to press Control-C. There's also a Node-RED stop command you can run. And what you need to do, you need to change into the .node-red directory under your Pi user home directory. And this is where you need to install different Node-RED packages. And you use the npm package manager. And so I actually need to do sudo apt-get update because you need to install it. It's not installed by default, which is a little bit unfortunate. I wish that Raspbian would come with like the latest Node.js installed, because there's so many ways to install Node.js over the years. Like, you know, way before the Raspberry Pi 3 came around and had the ARM v7, you know, people had these custom builds you had to go download. And so when you search for how to install the Node.js on the Raspberry Pi, you get a mess of documentation, which I really don't like. It's not easy for beginners to figure this stuff out. So just a little pet peeve of mine that it's, you know, it should be obvious how to get Node.js running, and it's not, in my opinion, with the Raspberry Pi right now. So, and I think Node.js is installed because obviously it needs that for Node-RED to run, but npm isn't installed, which is a weird, you know, like if you install Node, you need npm also. And then there's a whole other can of worms with the version of npm and Node that you get. And the Debian OS that Raspbian is based on has a pretty old version, and everything changes fast, so you'll kind of see. So let's try to install a package, but you're going to see that I'm going to run into some problems pretty quickly. And I figured out how to overcome them, but I'll show you that it's maybe not worth the pain right now to deal with this stuff. So, okay, so I did an update. Now I need to do sudo apt-get install npm to get the npm package manager. So we'll do that. Yep, we'll say yes. It's going to do its thing and install npm. And then after I do this, I can use the npm command like it shows right here. So, you know, you go inside that Node-RED package or Node-RED directory in your home directory, and then you run this npm command. And what that does is that uses Node's package manager, and it will install that package inside the directory that you're currently in. And because you're in that special Node-RED directory, that's where it's going to look for all these extensions like this. And so we'll see in a second here. So once it finishes installing, it just takes it a little while here. So it's going to grab npm. But we'll see what happens. So I'm going to try to install this. Now this library is maybe, well, it's a good and bad example. It's good in the sense that this library has to use some native code to talk to this sensor. Whereas other things, you know, maybe if things are talking to like I2C or SPI devices, they might not need to use native code. And when I say native code, like C or C++ language code. So it actually has to compile some code to make this work. And that's where you run into a lot of trouble with Node.js, and where we'll see some problems here. Because native code with Node.js has been a bit of a painful experience in my experience. Like, you'll get these very cryptic errors about If your Node.js version doesn't match your NPM version, and there's this tool called Node.jip that's used to do this native compilation, if all the stars don't align and you don't have the right versions, it completely fails and it's not obvious. You'll see all these errors of like, I'm looking for some symbol in a header and it's not there. And as a beginner, it's like, okay, what does that mean? It's like, it doesn't compile. Well, it means that the versions don't match up, and like you're using a later version of something and you have an earlier version of something else. And instead of figuring that out and giving you a useful error message that's like, hey dummy, you have the wrong versions, it just fails to find a symbol, and then you're scratching your head. It even boggles my mind sometimes when I get these errors. And it's so if at all costs, try to avoid doing native stuff in Node.js is my advice, unfortunately. And if you are doing native stuff, go straight to the bleeding edge versions, get the latest version of Node.js and NPM. Do not skip skip everything, go straight to that latest version, because there's probably broken stuff in earlier versions and you're going to bang your head against the wall and then install the latest version and it just magically works. So that's my advice with that, unfortunately. Okay, it's unpacking, and I think this is the last part of the npm install here. So yeah, processing the man page. So that's like adding, when you do the man command, it tells you how to use the tool. So that's usually kind of the last step of the apt-get install right here. So here we go. I think we're almost done here. And if you have questions, throw them into the chat, and then I might have some time here to do this. So yeah, it looks like some people have used Node-RED a little bit before. So okay, so come on, finish up this man page. Other kind of little nitpick, wouldn't it be nice if apt-get had a progress bar? That would be pretty slick if it told you, hey, I'm 50% of the way done. That would be handy. I'm sure that's been debated a lot, or there's probably a good reason why they don't have that yet. So okay, this could be a stream of just waiting for npm to install. It's normally not this slow, but when I'm streaming, it takes a lot of bandwidth, and so sometimes things take a little bit of time. And maybe if this goes for too much longer, we'll give it a second here and just kind of move on. Someone says they're following along. They're already getting errors. Sorry. Yeah, it's I started just from Fresh Raspberry and Jessie, the 527 image, so maybe try that. And like I said, also go back to the Node-RED documentation, nodered.org, and just read this whole Raspberry Pi page, because it has a lot of good tips. Maybe try updating Node-RED also. I haven't updated the latest version of it yet, so that's something to think about also. So okay, we're almost done here. Looks like we weren't really finished. Other little Node.js thing I hate is how there's so many little dependencies, which is cool in that like you build a complex system out of little parts, but man, there's a lot of code that has to be downloaded, and each one has a separate open source license. Basically, if you're trying to like commercially ship a project that in your business, or and you need to care about open source licenses, Node.js is a whole can of worms, because you might just include one little package that includes thousands of other packages, and suddenly you need to go figure out the licenses of all those packages, and some of them might not be compatible with what you're trying to ship. So anyways, that's a rant for another day. Finally, this thing's done. So okay, so now I can finally run that npm command. So let's go in here and let's go back to our library, and this is the command I need to run. So let's run this and see what happens with this. So we're going to try to install this DHT sensor. And so it first starts out, this is just an annoying thing with this package. You need to actually install this BCM 2835 library. So I'm going to do that. I'm going to go to the website that they mentioned. And this unfortunately has kind of an ugly install. You need to manually download the tar gz file, or copy the address to that. And then I probably want to go back to my root folder, because I don't want to install this in the Node-RED folder. And then I want to wget that file. So let's do that. Paste that guy in, and then I want to unzip it to tar xvfz, my BCM thing. And then this is a pretty typical Unix install, so you need to change it in the directory, run the configure script, configure, then run the make command. So configure is going to check you've got a C++ compiler and all that stuff installed. Run the make command to actually make the code, and then run sudo make install to install this library. Okay, so that hurdle's passed. Now let's go back to that Node-RED directory and let's run our command again. So we're almost there. There we go. So run this command again. Let's see what happens this time. Okay, now it's getting a little bit further. So it's going to try to install these native abstractions, and it's rebuilding the add-on. And then let's see what happens here. So it's compiling some stuff. And then, things start failing. So welcome to the fun of Node.js and native code. So this spew of error messages, which has, I would say, one of the worst error messages in the world. Basically, this is the error. The compiler can't find this replace invalid UTF as a member of the V8 string object. If you know intuitively what that means, you get a gold star because it is completely non-obvious what the heck is going wrong here. What's actually wrong is that the version of Node.jip that I have is too old, and it has headers for an older version of Node. It basically, Node.jip is what does this native compilation. So the versions are out of sync. It's not going to work. I stumbled through a way to make this work. So what you have to do, you have to npm install, sudo npm install -gn. And n is this tool that lets you install the latest version of Node.js. And then you run n latest, and that's going to run, you have to do that as sudo, so sudo n latest. That's going to install the latest version of Node.js on your system. So that gives you version 6.2.1. Then you want to exit out of your SSH session because when you run Node, it's still going to point at the older version. So I need to reconnect so that it gets, like Node 6.2.1 as the version there. All right, so let's give the password. We're not done yet. Now we need to sudo npm install -g. That means globally install. I need to install the latest version of npm and node-jip. So, okay, I hope you're following along. And it just boggles my mind, like, how would a beginner ever figure out how to do this stuff? They wouldn't. They would give up. So this is a rough edge, in my opinion, at least in the Node.js world. If they want to make this stuff easier for beginners, this is not going to cut it, in my opinion. So just be aware with this Node-RED. When you start running into weird problems like this, there's probably a crazy version of something that you don't have that's not working. So it's not pretty. But hope is not completely lost. You kind of have to go out of your way to run into these situations. Like, it's only when I'm trying to use this native code extension do I run into trouble like this. So, I'm not going to throw some blame on Node-RED. Like, it's not their fault for this. It's just a weird quirk of how Node.js moves very quickly. They break things a lot. And so, the newbies and beginners get left in the dust, unfortunately, with a lot of this stuff. So, okay, it's doing its thing. It's installing the latest versions of these. And hopefully in a second it's going to finish. This is kind of nice. I like this progress bar, at least. That's maybe a good model for different package managers. So it gives me kind of flashbacks to the old BBS days. Remember, you get like all the menus made out of these extended ASCII characters and stuff like that. Those were good days here. So I don't know what these, I guess those are like hashes that it's showing right there. You see like the weird little text that it has. So, okay, I think we're almost done here. So, yep. Okay, so that's there. Now let's go back to that Node-RED folder and let's try the command that we originally wanted to run. So let's try this guy. And I think this is going to work, although I'm not completely sure that it's going to work because, again, the Node native world is a bit of a mystery to me sometimes. So, okay, we're getting back to our install native abstractions. There we go. Finally, it built. So don't hit yourself or hate on yourself if you can't figure this out. Because it took me a while to figure this out even. So, and I don't even know, what is this error here? No ent, no such file or directory. That's cute. I don't even know what that means. So, hey, welcome to Bleeding Edge of Node.js. All right, so let's do Node-RED start again. And that's going to do its thing and start it all up. And now we should see. So, okay, yeah, so things are running. And let's go back and let's restart. Yep, leave this site. And okay, so Node-RED starts up. Now if I scroll all the way down, I've got this RPI DHT22 thing. So that's the new library that I installed. And so that whole process that I just walked through, the basic idea is you find your library, you go into that .node-red directory, you run the npm install command, cross your fingers and pray that there's no crazy native issue. If there is, you probably need to install the latest node jip like I just showed, and then try it again. And then when you run it, you should hopefully see your new thing here. Now, unfortunately, the story doesn't end here. I tried to use this and it just seg faults whenever I run it. So I don't know if this library works, unfortunately. That's maybe something to mess with for a future day. But I think that's it. I'm going to wrap up the stream right now. I basically just wanted to show the basics of Node-RED. Really just hopefully explain, like, what is this thing? You might see Node-RED, and it looks like a pretty cool graphical environment. I mean, you saw the basic stuff works pretty well, and you can wire things up graphically, and you can go pretty far with this, I think. And then there's a whole ton of libraries that they have that you can go even further with. So definitely worth checking out. I'm not going to say that it's like completely beginner friendly, but it's definitely easier, especially if you're not, wanting to get your hands dirty with just diving into code. It certainly has some promise and could be a little bit easier for that stuff. So, okay, so throw any questions into the chat, and I'll see if I can get to those. And then let's see, I'll jump back to the main view here real quick. So let's go here. And then, yeah, just some programming notes. So if you like this live stream, check out twitch.tv/Adafruit. I do these streams live. Subscribe to youtube.com/Adafruit. That's where I put these videos up later. And we have all kinds of other fun project videos. All throughout the week, we're doing lots of live streams and projects and things. I like to do 2 streams a week. So Mondays, I like to do a little quick look at Raspberry Pi software. Fridays, I like to do a deeper dive. So the last 2 Fridays, I've done a deep dive into using the SQLite database engine to store sensor data. And so really cool little series of how to store some of that data. This week, I won't have a Friday Pi stream. I'll be at Tour Camp, Toor Camp, which is a really cool kind of maker hacker camp thing out in Washington State. So I'll be gone Friday. Maybe I might be able to Periscope from that. We'll see what can happen from that. So no live stream this Friday, but I might do a live stream tomorrow. Basically, I did a fun little build yesterday of these Larson scanner shades, like the Knight Rider kind of blinking LED that goes back and forth. So check out the YouTube channel. You can see that. I'm thinking tomorrow I might do another little video to build some extensions onto that one. But anyways, then hopefully after this Friday, I'll be back to kind of the regular schedule of, at least 2 live streams a week on Mondays and Fridays. So I don't see any questions, so we'll wrap it up. So thanks a lot for watching. Hope you got some good knowledge out of this. If you like it, comment, subscribe, like, let us know that this is cool stuff, and we'll keep doing it. So this is Tony from Adafruit, and I'll see you guys later.